Hi students, good morning to one and all. Today we are discussing the third unit, second part of backtracking, the last application that is 0 by 1 knapsack problem by using backtracking methodology or systematic approach. Okay, already if you've seen in greedy method, dynamic programming, 0 by 1 knapsack problem. What is 0 by knapsack problem? The problem is similar in the sense same. The problem is similar to the 0 by 1 knapsack optimization problem. What is the meaning of the optimization problem? It is the best or most favorable solution in a given objective function that either maximizes or minimizes. That problem is dynamic programming algorithm. Okay, the problem here is similar to the 0 by 1 knapsack optimization problem, that is dynamic programming algorithm. In this knapsack problem, by using backtracking, we are given n positive weights. How many positive weights? Small n, within single quotes I indicated that small n positive weights wi, and small n positive profits p suffix I, and a positive number small m. That is the knapsack capacity. What ma? M is the knapsack capacity, bag capacity, m that indicates. That is a problem we need to call for choosing a subset of the weights, such that we are indicating here we are given n positive weights wi and n positive profits pi and a positive number m, that is the knapsack bag capacity. The problem that calls for you choosing a subset of the weights such that here the formula they mention summation of 1 less than or equal to I less than or equal to n, where I varies from 1 to n, wi xi less than or equal to bag capacity m, and summation of 1 less than or equal to I less than or equal to n, where I varies from 1 to n, p suffix I, x suffix I is maximized, where xi tends to constitute 0 by 1 valued vector. What ma? Where xi represents constitute 0 by 1 valued vector. So here the solution space is the same. The solution space is the same as that for the sum of subset problem. Already we discussed the sum of subset problem. It is equal to the solution space is the same as that for the sum of subset problem. Here we are studying bounding function. What function? Bounding function. It is needed to help to kill some live nodes without expanding them. Without expanding them, we need to help kill some live nodes. A good bounding function for this problem is attained or obtained by using an upper bound on the value of the best feasible solution. Okay, we need to get the best feasible solution obtainable by expanding the given live nodes. Listen carefully, ma'am. You need bounding functions to help kill some live nodes without expanding them. So a good bounding function for this problem is obtained by using an upper bound on the value of the best feasible solution. It is attainable by expanding the given live node. So here the profits and weights are assigned in descending order depending upon the ratio. Listen carefully, ma. Depending upon the ratio, we have to be calculated. The profits and weight are assigned in descending order. That is, I mentioned here, look at this, pi divided by wi greater than or equal to p of I plus 1 divided by w of I plus 1. Okay, where I varies from 1 to n. Here pi in the sense of profits, wi in the sense of weights. P of I plus 1 will be incremented divided by weight of I plus 1. Here the profits and weights are assigned in descending order depending upon the ratio. Now here we are studied about the solution. What the solution? 0 by 1 knapsack problem by using backtracking. What the solution if you need to get the profits and weights? What we have to take the first object, we are using the weights and check if the first weight is less than or equal to the capacity. So then we include that particular object, that is the unit is 1, that is k tends to 1. Here look at the solution, ma. What I said to the solution, after assigning the profits and weights, we have to take the first object weight and check if the first weight is less than or equal to the capacity, bag capacity. If so, then we include that object, that is the unit is 1, that is k tends to 1. Then after we are going to the next object, if the object weight is exceeded, in the sense greater than, is exceeded, that object does not fit, so unit of that object is 0, that is k will be assigned to 0. Then we are going to the bounding function. This function determines an upper bound on the best solution, an upper bound of the best solution obtainable at level k plus 1, obtainable at level k plus 1. So repeat this process until we reach the optimal solution. Repeat the process until we reach the optimal solution, in the sense best solution. Now coming to the algorithmic representation of bounding knapsack problem. Here look at the algorithm here. Algorithm B in the sense a bounding function knapsack problem. K, CP, CW. Here M is the size of the knapsack bag, N is the number of weights and profits, W of function and P of function are the weights and profits. P of I divided by W of I is greater than or equal to P of I plus 1 divided by W of I plus 1. Here the FW indicates final weights of knapsack, FP indicates final maximum profit. Here x of k will be assigned to 0 if W of k is not the knapsack, else x of k will be assigned to 1. We need to generate the left child. Okay, now if W plus W of k less than or equal to m, bag capacity, then y of k will be assigned to 1. If you have to check the condition k less than n, then bound knapsack k plus 1 comma cp plus p of k comma cw plus w of k. If cp plus p of w greater than fp and k will be assigned to n, then if we have to check the condition, final maximum profit will be assigned to the final CP, in the sense CP cost profit plus P of K, and if you have to assign it the final maximum of weights, that will be assigned to CW plus W of K. For if you have to write the condition, J will be assigned to K, do X of J will be assigned to Y of J. Then if we have to write the condition, if bound of CP comma CW comma K greater than or equal to FP, final maximum profit, then Y of K will be assigned to 0. If we have to write the condition here, K less than N, then the bound knapsack problem K plus 1 comma CP comma CW. Okay, if you have to check the condition, CP greater than FP and K will be assigned to N, then FP will be assigned to CP and FW weights will be assigned to CW. For J is equal to 1 to K, do x of j will be assigned to y of j. Then finally if we have to close the brace. Okay, this is the algorithmic representation of bounding knapsack problem. And coming to the bounding function of algorithm bound, it's a name cp comma cw comma k. CP in the sense current profit total, CW in the sense current weight total, K in the sense the index of the last removed item, the index of the last removed item. Now if we have to be calculated here, the bounding function will be assigned to current profit total and the current will be assigned to current weight total for I is equal to minus k plus 1 to n do. If you write the condition for I is equal to minus k plus 1 to n do, C will be current profit will be assigned to current plus W of I. If C less than M, then B is equal to B plus profit of I. Else otherwise we have to be written B plus 1 minus C minus M divided by W of I into P of I. Finally, if we have to be written the bounding function, here look at the conditions here. If you write the C is equal to C plus weight of I, if C less than the knapsack bag capacity, then bound is equal to bound plus profit of I. Else otherwise if we have to be written bound plus 1 minus C minus M divided by W of I into P of I. Finally if we have to be written the bounding function. This is the concept of knapsack problem by using backtracking. Here the problem is very similar to 0 by 1 knapsack problem by using optimization problem. It is given by dynamic programming algorithm. Here we have to be studied summation of 1 less than or equal to I less than or equal to n, Wi xi less than or equal to knapsack bag capacity, and summation of 1 less than or equal to I less than or equal to 1 profit I xi is maximized. Okay, here we are studied about bounding functions to help to kill some live nodes without expanding them. Okay, here we need to study about the best feasible solution obtainable by expanding the given live nodes. Okay, here we are writing the profits and weights are assigned in descending order depending upon the ratio. It is the concept of knapsack problem by using backtracking. Okay, Amma, if you have any doubts, can you please contact me? Thank you, one and all.